Hi everyone, Mrs. Moore here again. I'm just checking in to see if you saw that Mrs. Klein posted an assignment in her combined physical science Google Classroom. So if you want to check out that assignment, I will show you on my screen. You're all in this physical science Google Classroom. She posted a video that she wants you to watch. She runs through the notes and the vocab that you should all have copied into your packets. So she explains it a little bit more, and then she starts working on the worksheets and gives you some examples. So please make sure you're watching that. Also, she asks you to please finish the worksheet she's doing with you and to post a picture on it. Now, if you do not know how to post a picture, make sure you email me, message me, contact Mrs. Klein. She actually recorded another video right here. Right here. If you watch, make sure you watch that first of all. It's great to see Mrs. Klein. She instructs you how she wants you to upload things, and if you are having trouble uploading things, she gives you her phone number. You can take a picture and just send it to her. Again, if you're having any trouble uploading anything, please let us know. We can help you with that. But after you complete your worksheet, make sure you mark this as done, and then you upload your picture. Okay? You are able to upload it either using the camera on your cell phone, or you can use the camera on your laptop if you have one. If you go to the intervention Google Classroom that you're all a part of, yesterday I posted directions on how to use your laptop camera to upload. Okay, again, if you're having any problems with it, please let us know. Okay, so I will run through the worksheets again. This is the worksheets she wants you to complete and turn in. So we're going to be doing those together. Make sure, actually right now, put your name and P8 at the top of both of these worksheets. I circled name, name, and name. Write it on both sides and then put either P7 if you're in period 7 or P8 if you're in period 8. Let's get started. So she starts with this worksheet first with you guys. And in her video, she reads through it and she does part A and part C with you. I'm going to show you mine, but she does it with you, so make sure that you follow along with her. All she's doing is she's reading those directions right there and filling in the blank. So part A says a force is the 40 newtons, which you can see that I boxed in part A. The distance is 10 meters because it says the mover slides the crate 10 meters across the floor. Then you just multiply those together because that is what our formula is for this. Okay? So you're just multiplying those together and then you get 400 joules. Now, she also does part C with you. And she explains, if you look up in this diagram, it says no work is done in part C. You can see that I drew 2 arrows in. It's because they're not moving in the same direction, so no work could be done. So all you have to write is not in the same direction. Now, let's look at part B and part D. So for part B, the crate weighs 200 newtons, so that's going to be your force, and the distance, as listed in part B, is she lifts the crate 1 meter across the floor. So that's what you're rating for distance, 1 meter. So you should have 200 and 1, and you're going to multiply those together, and you're going to get 200. Now, part D, again, our force is 200 meters because that's how much the crate weighs. And this time she's moving it 3 meters above the floor. So you multiply 200 times 3. You can either punch that in your calculator or do that in your head, and you should get 600 joules. All right, let's flip sides. We're going to run through this together. Now, she does number 3 with you on her worksheet. So I will just quickly go over that with you, but we're going to start at number 1. So if you look up here, there are all your formulas. Again, make sure you write your name or P7, P8. And then your work is always going to be in joules. Force is going to be in newtons, and distance is going to be in meters. So make sure you are putting the correct labels on. Number 1, a book weighing 1 newton is lifted 2 meters. How much work was done? So our equation is W equals F times D, force times distance. So our work is 1 times 2, and our answer is going to be 2 joules. Number 2, a force of 15 newtons is used to push a box along the floor of a distance of 3 meters. How much work was done? Well, work equals force times distance. Write your equation down. Work equals 15 newtons times 3 meters. So we need to get 15 times 3. Once you punch that in your calculator, you should get 45 joules. All right, she does number 3 with you, but I'm going to review it quickly with you again because it's a little bit different. It took 50 joules to push a chair 5 meters across the floor. With what force was the chair pushed? So this time we are looking for how much force was used. We know the work and we know the distance. So I set up my problem, 50 joules equals F times 5. Okay? This way was easier for me to see, okay? So what you do is you try and get the variable by itself, just like a one-step equation. That's all it is. So you're going to do the opposite. Opposite of multiplying is division. So you're going to divide by 5 on both sides. Now the 5s, that's going to equal 1, so it cancels out. So we have 50 divided by 5, and that equals 10. So that's how we got our answer of 10. Number 4. Number 4 is very similar to number 3. We're going to set the problems up the same way. A force of 100 newtons was necessary to lift a rock. A total of 150 joules of work was done. How far was the rock lifted? So this time we have 150 equals 10 times, or 100 times D. So we know our joules and we know our newtons. We're trying to find our distance. So we have to get that D by itself. We're going to divide by 100 on both sides. The 100s cancel out because it equals 1. And then we have 150 divided by 100, and you should get 1.5 meters because we're looking for the distance. All right, number 6. It took 500 newtons of force to push a car 4 meters. How much work was done? Now we're going back to how we did it in question number 1 and 2. So our work equals F times D, W equals 500 newtons times 4 meters. So that's what we should have. Then you're just going to go ahead and multiply straight across. So your answer should be 2,000 joules. Make sure you put that label on there. Number 6. A young man exerted a force of 9,000 newtons on a stalled car, but was unable to move it. How much work was done? Well, this is kind of a trick question. This man might have exerted a force of 9,000 newtons, but if it was a stalled car, that means that it's not moving. The car was stalled. This young man was unable then to move it. So how much work was done? None. He was unable to move it, so your answer is going to be none. All right, so there you go. You now should have both sides of that worksheet complete. What I want you to do is take a picture of this, put your name and P7 and P8, and then on Mrs. Klein's Google Classroom, you are going to upload that right in here. Mark it as done and send your picture. Again, if you are having problems taking a picture or uploading that, please let me know so we can help. Good luck!